Hey boys and girls, Scotty the Redneck Canadian here. Welcome back to my channel, Scotty's Homestead University, where I try not to swear and offend liberals, and hopefully you learn something. And hey, thanks to my new subscribers. I'm getting back up to 1,000 anyway. I don't know, I thought about that the other day though. I really don't need money from being monetized, so is it really worth it? I mean, because, I don't know, you can't say the R word, like, the R word. It's retarded. Yeah, see, that would get me demonetized. And I'm like, I'm not making fun of people when I say it. It's retarded. So let's talk about some retarded things that I see, and some wastes of money where you'd be much better off. Let's talk about today inverter loss. Okay, so let's talk about inverter loss. Let me explain it to you. And I've been doing this now for almost 3 months since I started tearing my whole life apart to go off grid. But it's working out really well, and I've got some really good solutions. And I apologize for not making videos. Like, it's been a couple of weeks because I've been trying to deal with selling my house downstate, and I've been waiting for things like this because I didn't just want to make a video just to make a video. So, all right, inverter loss. All right, so here is the inverter that I've been using. This is a low frequency Sun Gold Power. You've seen it before. It's a little loud, but it is what it is. It's running a 1.5 horsepower pump. You can see it's like at 6%. It's like way more than I need. But when that pump kicks on, sometimes it hits pretty hard. Anyways, I got a plan for that too. That's not even going to cost me any money. But the deal is with this is there's a switch up here that'll put it on like low power mode, and then what it pretty much does is shuts itself off unless there's a load that's more than 25 watts. Then it turns itself back on. And the reason is, I believe when I looked at this like 2 months ago, whenever I got this thing uses like 80 watts just sitting there. Okay, so it's almost like having a 100-watt light bulb just sitting there. And there's a few ways that you can get around this, and one of them costs a lot of money and one doesn't. So let's talk about these two ways. And then the other thing with inverter loss, it's just inherent in this, is that when you do put a load on, going from DC to AC, this thing eats up about 8 to 10%. It just does. It's the nature of the beast. So when you start adding up your wattage, you got to add 10% to it to figure out what you actually need as far as battery power. So, all right, let's talk about how we're going to mitigate this. Okay, I'm going to have to go find some paper somewhere. That's a set list that I used the other week. Anyway, if we got 80 watts an hour times 12 hours at night, we're going to use 960 watt hours, which is like half of one of those 50 amp hour, well, 24 volt 100 amp hour batteries, right? It's almost half. So that's unacceptable. So there's a couple ways around this, like I said. So the first is that you could buy a Victron Phoenix inverter, okay, which is like super efficient, and but that's $334. They make another one that's smaller, that's less, but I mean, if you're gonna buy an inverter, go big or go home, right? Like, buy the one. So this is the biggest one that they make in that. And then hopefully this works. Here we go. Okay, so for a little bit less money, you could get a 50 amp hour 48 volt battery, which is going to give you like 2.5 kilowatt hours. So if you're going to do something, if you're going to buy something, I would submit that you're way better off buying more storage, okay? Because you're going to be saving a little bit less than 960 watt hours per night, but that's going to give you 2.5 kilowatt hours of storage for less money, okay? And so the best way though is to go with these dealies, which are DC to DC buck converters, and to shut your inverter off. Okay, so let's go over what these things are. They're pretty cool. Okay, so I went back through my Amazon and eBay purchases, and so here's how I'm going to deal with my quote-unquote problem. Okay, and the problem being, we're going to lose almost a kilowatt hour a night just by leaving that on. Okay, but I really don't need it on because, as I'm going to show you, I figured out a way to deal with the refrigerators. They don't need to be on all night because nobody's opening and closing the doors. But what I do want on is my electronics. So up here, I've got my security system, and I got my Wi-Fi router, and I've got my fiber optic modem, and then also included in there is a LAN to optical converter. It's just a little box, you can't see it, but that's what sends my internet from here back to the barn. Okay, and this is, so what you got to understand is when they say, okay, pure sine wave inverter, you know, for your electronics, blah blah blah, for the most part that's not true, because all this stuff runs on DC, and if we're losing, you know, 80 watts an hour just by that being on, plus we're losing the 10%, okay, we're just giving away a bunch of our free power for nothing. And then on the other hand, you've got wall warts that are consuming power, taking the AC from here and converting it back to DC. So it's a lot more efficient just to run some wiring and make ourselves a little box up here where all our stuff is, to run it just straight DC off of those 48 volt batteries. So I'm going to show you what we need to do that, and I'm going to do it. And then the other thing is you want to be able to charge your phones and things like that, and you can do that straight from DC too. There's no point in going from DC to AC back to DC. All right. Okay, so what we're going to need is we're going to need a buck converter that goes from 48 to 12 volts. This is a big one. I ordered big ones. This is way bigger than I need. This is 20 amps at 12 volts is a lot. Just because I got the golf cart out there, and I got them two at the same time. So, and then this little guy here goes from 12 volts to 5 volts. Okay. And then, so that's going to go straight off the battery. And then this goes from 12 volts to 5 volts and directly to USB, right? So the cost on these, so I'm not even going to buy another battery because I don't need another battery, right? So, but if you wanted to do all this together, including a battery, it's going to be $382 because there's 5% off of that battery, versus the Victron inverter is $379. So basically, it's the same price, only here you're getting an inverter. And now granted, if that inverter goes down, you've at least got a 1200 watt backup inverter. So I mean, there's something a little bit to be said about that. But if you're not really worried about it because you've got a good inverter, thinking this is the way to go. And in my case, I'm not even going to add the battery, because when that golf cart becomes useless in the wintertime, I'm going to take the 100 amp hour 50 or 48 volt battery out of that and add it to my stuff. So I'll have almost 20 kilowatts of reserve power. So anyways, you get your buck converters. So the 48 to 12 volt one is like 13 bucks. You get two of the 12 to 5 volt ones for 10 bucks. These, I mean, they're like 7 to 10 bucks, whatever. There's different ones that you can get. So I'm just going to say 10 bucks. And then what you need are these cable ends. So there's 2.5 millimeter by 5.5 or whatever. And then there's 2.1. So I think that's 2.1 and that's 2.5. So what you got to look at is the wall warts for each of your things. So in this case, let's see if I can zoom in. This is the dog fence. So in this case, you can see there, its output is 19 volts. So we would need a different buck converter to do this. And the positive is on the inside and the negative is on the outside, which is pretty standard, but you should always make sure of what's going on there. So in the case of these though, some of that stuff runs at 5 volts and some of that stuff runs at 12 volts. So what I'm going to have to do is I'm going to have to make a little schematic up. So we're going to have to go 48 volts into here. 12 is going to go into some pigtails that run our stuff at 12 volts up here. Okay, and then it's also going to have to go into this one to convert it down to 5. And then it's going to go into wherever I'm going to put this. or I'm probably going to get some different ones of these and put one up in the loft and put one over here. But that will then allow us to run all of this stuff straight DC without the inverter on. Because what I do at night, oh yeah, and these things are cool too. I got these motion sensing lights. They were like 11 bucks for 3 of them. I might go get 3 more of them. They're pretty bright because I got a little cabin. So what I've been doing is just turning the inverter off at night, which I like because that's kind of a bright light anyway. And it fixes all my problems. I'm not losing the kilowatt hour while it's just sitting there doing nothing, okay? But then the thing is with the refrigerators, okay, is you don't want them running at night anyways. It's a waste of energy. Nobody's there opening and closing the fridges all night, so you really don't need them. And just like the water tank, okay, this is getting finished today. This is another thing about the water tank I talked about. My fix for the summer is I detached one side because it's on right now and it's not hot. You can see it's not melting, but with both of those on, it got so hot that it actually started melting the insulation on the wires. And not because the current was a problem, but because the actual temperature of this was not getting cooled sufficiently by the water inside. But I'm gonna fix that today. And again, that's only for a couple of months in the summertime when I'm not running the wood stove. This works amazingly. And it would kind of be nice to get this pump down here to run off of DC, but I don't know if that's gonna happen or not. But this works so well that you really don't need to circulate it overnight anyways to keep the water hot. But all right, so let's see what we got to do here. I guess it's time to tear this all apart. Okay, so the second thing we're going to do is this is a LAN to optical converter. There's another one of those on the other side because it goes fiber optic back like 700 feet to the barn. But this is where we got to be careful because this runs on 5 volts center positive. That runs on 12 center positive, and they're the same pigtail. So I'm making myself a little list and a little diagram so that, because if I run 12 volts into this, I'm pretty confident I'm going to be out 40 bucks. So we'll make a list, and we're going to make sure then that this goes from this into this 5 volt, and then that pigtails that. I'm thinking I might be better off mounting everything to a board. Because it all sits up there, nothing, unless something bad happens. That's my bread is finished baking. Yes, you can use a bread maker. It's not cheating. Anyway, so yeah, what I think I'm going to do is I'm going to go out and find a board and plane it real smooth so I can use double-sided tape, and I'm going to tape everything down to absolutely make sure that I don't blow any of this shit up. Okay, so the first thing we're going to start with then is the Arlo base station. So it's 12 volts, 1 amp, and the positive is in the center. So what we need to do is figure out what size pin that is. Oops, which I believe is these ones. So we're gonna have to make ourselves a little wiring diagram because I'm gonna have to solder all this up and make it all work. All right, so I decided to make myself a little board here. I am missing the 9 volt one for the Wi-Fi, but I'm pretty sure that I can put the LAN to optical converter here and the Wi-Fi on this board, and then the other two things can just sit in front of it and it'll look good. So I've got it hooked up to the golf cart battery right now. We got 5 volts coming out of here, 5.2 volts, and take one of these, one-handed, always not easy, into the middle, and there we go, 12.27 volts. So I'm going to take this up front and put it together, and everything except for the Wi-Fi should work off of it. All right, so I'm not going to fix my board yet because obviously I got to put the 9-volt for that. But we're going to go over here and shut the inverter off. And voila. We still have internet. And it's still pumping internet out to the barn. And the security system's on. So, and then what do we got here? So 224 watts going into the battery. Let's see what happens when we turn this back on. So it's about 180. Just everything idling, the TV, all that kind of stuff idling. So, I mean, that's quite a bit to knock out 180 watt hours times 12 hours is a lot. So, all right, that's how we did it. Oh yeah, and in case I didn't, so I've got a breaker here that goes to my hot water tank, and I ended up unhooking half the element, so now I can turn that on and off. It only takes about 45 minutes a day to really get the water cranking. Gives me hot water for the rest of the day. So we're getting there. It's getting there. I got to work on this next and get this propane tank the heck out of the house. So it's coming along. I got the stuff. I found the stuff for this out in the barn too. So this is going to be a charging port for the golf cart. One of them. That one there. It's a golf. You can't really see. There you go. It's a golf cart charging port. And I made this cable so it'll plug right into the golf cart. I just pull it up there. And then this one's for a generator. Just in case I ever have to plug in the generator and charge the batteries in the wintertime. So, all right. I need to clean the rest of this place up now that I got all this done. Till next time, keep your sticks on the ice.